Hello, welcome. Let's try to solve another Leetcode problem, 456, 132 pattern. So I've solved this problem before by using sorted list. So the sorted list idea is that, because this is helpful for us to understand why we can solve it by using monotonic stack. So let's first try to solve it by using sorted list. I will not code it up by using the sorted list, but I will explain the idea of the sorted list because this is helpful for us to understand why we can solve it by using monotonic stack. So for the sorted list idea is that for each of the steps, first of all, we're gonna find the minimum number. So for example, for the first number, it is 3. Basically, we find the minimum number, it is 3. And then we're gonna find the next number. So for the next number, so what is the minimum number? It is 1. And what about 4? The minimum number is 1, and up to 2, the minimum is 1. So normally we can find the minimum number for each of the steps. But for the sorted list idea is that while we are checking this number, for example, this number, let's check this number 2. So while we are checking this number 2, so 2 is smaller than 4. So if this 2 is greater than 1, so we find a solution. Because this meets the condition of nums I less than nums k, nums less than nums j, and I less than k, I less than j, less than k. If it can meet this kind of condition, normally we can find a solution. So the idea is that we're gonna put all the numbers inside a sorted list. So in Python, the sorted list is like a balanced tree structure. So we can find a number in log n time. So basically, it is a balanced tree structure. So we can find a number in log n time. So for this number 2, we're gonna put some numbers inside of the sorted list. So for example, we're gonna put the last two numbers inside of the sorted list. So for 4 and 2, we're gonna put 4 and 2 inside of the sorted list. So it's gonna be 2 and 4. And then by using those two numbers, we want to find another number. So up to here, this number is gonna be the smallest. It is 1. So inside of the sorted list, if we can find a number, so for example, this number 2, if we can find a number 2 that is smaller than 4 and bigger than 1, basically we find the solution. So for the next number, we're gonna use a binary search to we're gonna use a binary search to check if it is inside the sorted list. So let me just use the sorted list code, maybe from somewhere. Let me explain it. So for sorted list, we're gonna take the last two numbers. We're gonna put it inside a sorted list. So for example, this 2 and 4, we're gonna put it inside the sorted list. And then we're gonna record the minimum number, the smallest number. So for example, currently the smallest number is 3. Because the number 0, it is 3. And then we're gonna enumerate from index 1, for nums from index 1 to the to length of the nums minus 1. So this means this is similar for j. And then so this I, we're gonna make it to j. And then we want to find an index k. and then we want to find an index k. If k is less than and this is less than nums j. Yeah, basically we want to find an index by using binary search to the right. So if we can find an index k, yeah, so the first condition is if nums j more than minimum number. Yeah, so for example, for this number 4, so if this number 4 is more than the minimum number, and the minimum number is 1, yeah, let me use just this array. So for example, if we find a number 4, it is more than the minimum number, and currently the minimum number is 1. So this basically means we find a condition. Yeah, we find some numbers that is more than 1, and then we can use a binary search, bisect right, to check for this number, for the minimum number. Yeah, so the minimum number is 1, but inside the sorted list, we're gonna find a number more than 1. If we can find a number more than 1, and it is not this and it is not this j, because we removed this number. Yeah, if we can find a number which is 2, basically we find the solution. Yeah, because this 2 is inside the unsorted list. If we find this number 2, basically this 2 must be bigger than 1. Yeah, because if must be bigger than 1, because inside the sorted list, if yeah, but currently for our example, maybe it has only a number 2. Yeah, but when we can find this number, basically this number must be more than the smallest number if it is inside. So the sorted list idea is like that. And then this number, we're gonna check if this number 2 is less than 4. So if it is less than 4, so we're gonna return true. And then we're gonna record the minimum number, and we're gonna remove the nums j plus 1. Yeah, because basically inside the sorted list, it is just a number of nums k. We just need to check this nums k. And the minimum number is for nums I, and currently we have nums j. If the nums j more than nums I, so the minimum number. And the second one is we want to find an index k. That is by using the bisect right. So if it is less than nums j, basically this sorted list of SLK would be bigger than the minimum number. This is because if there's some number inside, for example 2, we used the bisect right to check this minimum 2. If we can find a number maybe 3, maybe our if it is like this, we're gonna use the bisect to check this number 2. If it is always to be 2, then k should be equal to length of the sorted list. Yeah. So if it is not, we still check this number 2. Maybe maybe this is 3. Yeah, maybe this is 3. We're gonna use the bisect right to check this number 2. So it's gonna be in this position. It means that this is 3. So this 3 must be more than the minimum number 2. Yeah. If it is less than length of the sorted list, it must be more than the smallest number 2. Yeah. So the idea of sorted list maybe we just fix the minimum number, and then we're gonna find nums j and nums k. If it meets the condition, so basically we're gonna return true. Otherwise, we're gonna return a false. Yeah. Now we are going to solve it by using the monotonic stack, because this is just ON time. So the idea is the same. We just prepare a prefix minimum. Yeah, so the prefix minimum is equal to nums, and then we're gonna check the prefix minimum number. So for I in range from 1 to length of nums, and we're gonna check the prefix minimum, gonna be the minimum of a prefix minimum. So here a prefix minimum I should be equal to the prefix minimum of I minus 1 and nums I. Yeah, so in this way basically we can check the prefix minimum number. Let's just print out the prefix minimum number. Yeah, because we're gonna use it later for the pattern check 132 pattern. Let's just try to run it to check what is inside for the prefix minimum. Let me just return a false. Yeah, let's just check this second example. So for the second example, basically we're gonna get a 3111. So this is useful for us to solve the problem. So first of all, we're gonna fix the prefix minimum, and then we're gonna find some numbers. Maybe this number is we find 2 numbers. Basically, it's gonna meet the conditions of like 4-2. If we can find a 4-2 tuple, basically we just need to check if this 2 is more than the minimum. If this 2 is more than the minimum, so we can return true, otherwise we're going to return false. Now the problem becomes easier. So while we are going to find the 4-2 pattern, so this is a monotonic stack, we just need to find the next smaller element. So for this number 4, we want to find the next smaller element. If we can find the next smaller element, so it is a 2, what are we gonna do? We're gonna compare this 2 with this minimum of 1. If 2 is more than 1, so we're gonna return true. Yeah. So the idea becomes find the next smaller element in an array. So yeah, we just use the monotonic stack to solve it. So we're gonna prepare a stack, and then we're gonna enumerate the nums. So for I in range, I will not enumerate. So I'm going to start from the first index because I have the prefix minimum number. So I'm gonna start from the first index because I want to basically find a tuple. So the tuple would be from index 1, not 0, because 0 is the minimum number. Yeah. So from 1 to length of nums. So I'm going to check the stack. So while the stack exists and my current number is nums I. So currently for this index, I want to use index k because basically this is for k. So I want to use it as nums k. It means the last number. Yeah. So if this nums k, basically I want to find the next smaller element. Yeah. So this means this means if this number is bigger or more than this number 4, I want to pop it out. So if this number nums k, for example, it is 2. If it is more than and equal to the number on top of the stack, I will pop it out. If I pop it out, for example, this number let me just start coding, and if there's any problem, I'm gonna fix it. Yeah, so if nums k more than and equal to nums stack and minus 1, and basically I want to pop the index. So stack would pop stack would pop the index. So for example, if this number is 5, this is 4. If this number is 5, it is more than equal. I gonna pop it out. Yeah, and if it is a 2, I just put it inside. Yeah, so basically this means this number 2 definitely it's gonna be smaller than the number on top of the stack, if there's some number on top of stack. Yeah, so basically I want to keep a monotonic decreasing stack. Yeah, so this means if it is more than equal, I'm gonna pop it out. Yeah, and then my stack is okay. I'm gonna have a stack like 4, but I didn't put 2 inside yet. But this 4 is useful because this 4 definitely gonna be more than this number 2. Yeah, so so while I meet the condition, I'm gonna pop it out, and then I want to check if I can meet the condition or not. If there's something inside the stack, and my current number is this nums k. If this nums k is more than the smallest number, because definitely this nums k is smaller than this nums j, and then I want to compare this 4 maybe bigger than this nums 1, the minimum number. So how can I find the minimum number? Yeah, so the minimum number is inside of the stack. It's gonna be stack minus 1. So this is gonna be the index for this number. Yeah, so J is the index for this number 4 because I didn't pop it out. It's not. So yeah, if I didn't pop it out, so I want to find a index. So the stack minus 1 is the index for this number 4, but I want to find an index before it. So it's gonna be stack minus 1 and minus 1. So this is gonna be the index for this number 1. And so I'm gonna check if this 2 is more than 1. So I'm gonna use inside the nums. If it is more than this number, definitely I can return a true. Otherwise, I'm gonna return false. So this is gonna be the entire code. Let me just run it to check. Something wrong with it. Yeah, because I forgot to put the index k inside of the stack. So stack should append this index k. So that is why I believe. Let me just run it. Yeah, as you can see, it works for those testing cases. Now let me delete the print and delete these areas and submit it to check if it can pass all the testing cases. Something wrong with this one. This is not expected. So here we're gonna find the smallest number for each of the time, and if stack exists, and nums k is my number. And this is more than equal. Yeah, let me still use this example. So this is more than equal. I'm gonna pop it out, and if a stack exists and this number nums k is more than nums stack minus 1, it is not nums because I calculated the prefix minimum. So it is not nums, it is the prefix minimum of, yeah, because I want to check the minimum number. It is inside the prefix minimum string. So I'm gonna use this one, and this is the index, stack minus 1 and minus 1. Yeah. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases, and it is much faster than before because we used monotonic stack. Yeah, so I believe for monotonic stack, basically we need to have the basic pattern, and then we need to check and find where we need to compare. Basically, there are 8 different cases. It is greater than or equal, smaller than or equal, or we can also compare with the previous number. It is greater than the previous number, or smaller than the previous number. Yeah, basically there are 8 different kind of cases, but no matter which case, we need to check if this is a monotonic increasing or monotonic decreasing. Yeah, I think that's for today's question. Thank you for watching. See you next time.